Hello, Mr. Munyon here with activity 35.3, focusing on density. So in this activity, what we're going to be doing is using the same three-dimensional shapes, pyramids, prisms, cones, cylinders, that sort of thing, but focusing on finding the density of these three-dimensional shapes, or using density to find weight based on the three-dimensional shapes. So here we're going to be looking at a couple of shapes. It tells us that we have, they're going to be comparing shipping based on the cost for the packaging material, so using the surface area, and based on the volume, how much these different containers could hold. So we have a couple of, well, it looks like we have 4 different items here that have different densities, and we want to be able to compare based on how much the shipping materials or the shipping cost and the packaging materials cost per square foot. We're going to be comparing all of that, making a cone, a pyramid, how much that cost, filling it with different items, how much it would cost to ship. Okay, so question 1 says consider the cone. The diameters got labeled on there. We have the slant height, 6 feet. Okay. It says determine the surface area of the cone and then find the cost of the packaging material. So surface area of the cone, we start with the formula. Surface area equals pi RL plus pi R squared. And we just need to plug in the pieces that we know. Radius would be 2.5. So multiply those and we get 15 pi plus 2.5, we get 6.25 pi for a total of surface area equals 21.25 pi feet squared of material. All right, if we plug this in our calculator with pi, we get that the surface area equals approximately 66.7588. And then now we can use the cost of materials to figure how much that would cost to make. So 45 cents per square foot, so multiply that by 0.45 and let's see what we get. The units for square feet cancel out, and let's see what we get here. 30.04 for the dollar amount. So cost was 30.04 for just the shipping materials. The next thing says determine the volume of the cone. So this one should be a little bit easier because volume just equals 1/3 area of the base, so this will be pi r squared, because the base of the cone is a circle, times height. So we do need to solve for the height. The radius will be 2.5, but we do need to solve for the height on this one. We do need to do a little bit of Pythagorean theorem here. So 6 squared, 36 minus 6.25 gives us 29.75, so square root of 29.75. So square root of 29.75 is about 5.45 approximately. So go ahead and plug that in, 5.45. And so we get 1/3. Pi radius was 2.5 squared, and the height was about 5.45. Let's go ahead and put these in the calculator here. So in the calculator, 1/3 area of the base times height, we get about 35.696 for the volume of that one. So 35.696. And units would be feet cubed for volume. All right. What is the relationship among volume, density, and mass? This is something you might not be familiar with. Most kids aren't introduced in middle school. Some don't learn it until physics. Density is just mass divided by volume. And an easy way to remember this is the units tells you what the relationship is. So density is equal to mass in pounds divided by volume in whatever units you're going to use. Same thing. The mass could be kilograms, could be pounds, and the volume could be in cubic feet, cubic centimeters, cubic yards, whatever. But the units tell you what the density is based on those units. So it helps you remember that it's mass divided by volume for density. So density is just equal to mass divided by volume. Find the mass of the cone filled with coffee beans. So the density of coffee beans is 22. The mass is what we're solving for, 22 pounds per cubic foot. And the volume is going to be 35.696. So then all we have to do is multiply both sides by 35.696 to get the mass. And we get the mass equals... All right, so here we end up getting 785.319. So 785.319. And this mass would be in pounds for this one. Oh man, that's kind of a lot. Does this make sense for us? 785 pounds? Well, if you have a 5.5 foot tall container filled with coffee beans, yeah, it's probably 5 feet wide, diameter at the base, 5 feet tall. It's going to be pretty heavy. So this answer does make sense, 785, because it is such a big container. So find the shipping cost of the cone. We can take the shipping cost from the, I guess we'll do the shipping cost and then we'll do the packaging cost. So the shipping cost up here tells us it's $1.90 per pound. So multiply this by 190. There we go. So 785 pounds times 190 per pound gives us a total of $1,492 for shipping. So 1492.107. I guess if you round to near cent, it'd be 0.11. So and then what is the total cost? We could just add that $30 for packaging that we came up with. So $14.92 would be $15.22.11 should be the total cost. Oh, whoops, 0.04. So 15 should be at the end there because add 4 cents to that as well. So. All right, so now that we have this, we're going to be comparing it to the other container as well. So this first question is kind of interesting. I actually like it. It just says make a prediction whether you think the other container is going to cost more or less, and explain our reasoning. So the dimensions are pretty similar, but a couple things I want to point out is that if the whole diameter here is 5, that means that the entire base would fit inside this and then extra outside of that. In addition, I know that the height of the cone was only 5.45, so I know that the height here is 6 feet. So it's actually even going to, not only is the base bigger, but the height goes up more as well. So it's going to have more stuff in there. And I'm assuming it's going to be more expensive to ship, but the total cost per pound might be what they're interested in. So we'll see. I think it is going to be more expensive for this container just because the base is bigger and the height is bigger on this one. All right, so let's, I think the pyramid will be more expensive. Capital B base and height are bigger. All right. Determine the validity of your prediction by analyzing the pyramid package. Okay, so we got to do all the work right here. I'm just going to put the answers I got. If you want to do them on your own, you're welcome to do that. But I'm going to pause here and then put the answers up. All right, so here we have all of the work for figuring out the cost of packaging. Be about $40.5, a little bit more expensive. The volume ended up being more as well. We got a volume of 50 cubic feet. If it's 22 pounds per cubic foot density, then it's a total of 1,100 pounds, and at $1.90 shipping per pound, the shipping would be $2,090. So this one definitely ends up being more expensive. The shipping or the packaging cost more, the shipping cost more, and then the overall cost is more as well. But you are shipping more product, so it'd be interesting to compare the total cost per pound that you're shipping, because if you're getting it, obviously it costs more, but you're getting more coffee as well. So on the next question, it says compare the ratio of total cost to ship to the volume. So for the cone, it only cost us $15.22, but we only got a volume of 35 cubic feet, or it cost $42.64 per cubic foot. So it's $42.64 per cubic foot. For the pyramid, when I compare the total cost over the volume, it only costs $42.61 per cubic foot. So this one, $42.64 versus $42.61, this one is slightly cheaper. You're saving 3 cents per cubic foot, actually. And if you have hundreds of cubic feet that you're shipping, if each one of these containers is 50 and you ship out a bunch of them, then that would be a substantial savings if you're shipping out a bunch of cubic feet. 3 cents for every cubic foot. All right, so then the next question here says, which food product in the table would be the least expensive to ship? Well, all the packaging costs would be the same, but regardless of which container you used. So the only thing that would make the difference is how much we paid for shipping. It's $1.99 per pound, so which one ever weighed the least amount would be the cheapest one. So whichever one is the least dense, the least amount of pounds per cubic foot, would be soybeans. So because it's the least dense, that means filling up that container, it's not going to weigh as much, so it'd be the cheapest to ship. All right, so soybeans because they are the least dense. All right, so now let's practice some. It says apple seeds are packaged in containers shaped like square pyramids. Coffee beans are packaged in identical containers. Do the filled packages have the same mass? If not, explain why. So if you take the same square pyramids and you put coffee in one and apple seeds in the other, are they going to weigh the same? No, because they have different densities. Which one is going to weigh more? Whichever one is more dense. So if I compare apple seeds and coffee beans on the table up here, apple seeds are more dense than coffee beans. So even if you put them in the same container, the apple seeds will weigh more because it literally weighs more pounds per cubic foot. So if you have the same amount of volume in there, every 1 pound is going to be every 1 cubic foot is 32 pounds of apple seeds, but every 1 cubic foot of coffee beans is only 22 pounds. So the apple seeds would definitely weigh more because they're more dense. All right, number 7, shelled almonds are packaged in a cylindrical container, blah, blah. What is the approximate mass of almonds that will fill the container to the nearest pound? Okay, so let's figure out how much volume is and then use the density to figure out how much that weighs. So we should be able to do this one over here. Cylindrical container with a 0.5 foot diameter and a height of 0.6. So diameter is 0.5. which means the radius is 0.25, and the height of this cylinder is going to be 0.6 feet. All right, so first let's figure out the volume. I know volume is area of the base times height. So area of the base is a circle, pi r squared, times height. If I plug in my pieces, pi 0.25 squared times the height of 0.6. Let me check this one in the calculator and see what I get. All right, it looks like we get the volume is about 0.11781. So 0.11781, and this would be in feet cubed for volume. Okay, now that I know the volume, I should be able to figure out how much it would weigh for almonds. So let's scroll back up here and check. The almonds are 30 pounds per square foot. I'm going to go ahead and rewrite the relationship between mass and density. So density equals mass divided by volume. And I know the density is 30 pounds per square foot, or cubic foot, equals mass is what I'm solving for, and volume is 0.11781 feet cubed. So in this one, multiply both sides by 0.11781 cubic feet. Over here, you'll have the cubic feet cancel out, and you'll figure out whatever pounds we are. So let's plug this in our calculator. 30 times 0.11781. And it looks like we get 3.5343. And the units would be pounds on that one. And that makes sense. It's 30 pounds per cubic foot. This is about a little bit more than 1/10 of a cubic foot. It's not anywhere close to 1 full cubic foot. 1/10 of the weight. 3 pounds would be exactly 1/10, but it's a little bit more, so a little bit more than 3 pounds. This answer does make sense on this one. All right, same thing with lesson practice that we did earlier. I'm just going to put the answers on here, and you can check your work. If you learn nothing else from this lesson, you need to make sure that you know the relationship between density, mass, and volume. Easy way to remember this: if you're going to get a driver's license, you need to go to the DMV, or if you remember the units that you're using, pounds per cubic foot is mass over volume to get density. All right, I'll put the answers up here in just a moment. All right, so 8, a little bit tricky because actually it gives you the density in pounds per cubic foot, but then it gives you the dimensions in inches. So you could either convert the cubic feet to cubic inches, which is a lot. It's like 1728 cubic inches per 1 cubic foot. Which makes sense. If you have 1 big cubic foot, there's going to be a lot of inches in there. So that's 12 by 12. That's already 144. And then do that again. You get a bunch more. You're going to get a bunch of layers of 144. So it ends up stacking up really quick there. So you could divide 54 by 1728 to figure out how many pounds per cubic inch. And then when you figure out the volume in cubic inches, multiply it by that to get your answer. Or you could convert all of these to feet. A little bit uglier because you get a bunch of ugly decimals, but either way you get by about 1.008 pounds, so about 1 pound of butter. Question number 9 is asking about a cone and a cylinder with the same base and height. Both containers are filled with shredded paper that has density. Which container has the greatest mass? Well, since they have the same density, it's just whichever one has the greatest volume. And obviously a cylinder would have a greater volume than a cone, and we can tell from the formula. Volume of a cylinder equals area of the base times height, and volume of a cone equals 1/3 area of the base times height. So obviously the relationship is the cone is going to be 1/3 the volume of whatever the cylinder is, and because they have the same density, it'll be 1/3 of the weight as well. So the cone equals 1/3 of whatever the cylinder is. Part C says determine the mass of each container. Are our answers reasonable? Yeah, the cone weighs 301, the cylinder weighs 904 pounds, which is about 3 times as much, I guess. 903, the 59, yeah, so about exactly 3 times as much. I mean, based on the formula, should be exactly 3 times as much. Number 10, this is kind of just to make your best judgment on this. If you have a really dense stone, would it make sense to package it in styrofoam? No, styrofoam is not going to hold super heavy stuff. So 1,281 kilograms per cubic meter, that's like over a ton per cubic meter. There's no way styrofoam would hold that. So use common sense on number 10 there. All right, we're done with 35.3. Make sure you do the lesson practice homework, and there's even some extra questions other than what's listed for homework that I would suggest you practice with. See you guys on the next one.